So with respect to these questions on the Monopoly homework, um, you might see something similar on the final, or our last midterm. Or when I say final, you all know what I mean. So I'm just going to say final, even though it's before finals week. Okay, but our last required exam in the course. But if you see questions like this, they'll be a little bit different and a little bit easier, because and I just want to talk with, let's see. So Andrew, I heard you clearly. So why don't you chat with me for a minute? Just make sure I'm getting all this down and everybody's hearing it. Are you there, Andrew?
Yes.
Okay. So remember I said, because you're gonna have to respond. You might as well leave yourself unmuted unless you've got a dog barking in the background, Andrew. But do you remember, Andrew, I said that we wouldn't be dealing with marginal cost curves on our final exam that had non-zero vertical intercepts. Do you remember that?
I think it was in one of the playlists from last year.
Well, it might have been, but I said it on. Do you guys, Scott? Do you remember me saying this to you on Tuesday?
Yeah, I remember you saying it.
Yeah. So, and for that reason, I want to say that the questions that you all are asking about do have instructive value, because you're learning something that's interesting, important, and all the rest of it. But they at this point don't have a lot of practical value. They have some practical value, because if you say, oh well, what would this be like if I saw the exact same question, but and hopefully we're all on the same page. Is there anybody that doesn't understand what I'm saying, William or Hung or Brian? If you don't understand, then you should say something. But so you could see this exact same question, but the marginal cost function it would just be, in the case of MC1, it would just be 4Q, and MC2 would just be 4Q. And this is like from our notation before, it'd be like Q1 and Q2, the output of those firms. So that's the practical value is, okay, what would this question look like? But the question gets a lot easier when you have a zero vertical intercept. And that's really the point that I'd like you all to think about as we go through these, because a little bit of the challenge on these problems later on has to do primarily with this issue of, okay, there's a non-zero vertical intercept, and it's only that issue. And so I do have extensive lectures on this, but I'll just show you guys really quickly, and then we'll go ahead and go from there. But let's focus on question 15. And when we're talking about these things, we have to be really, really careful with the language that we use to describe things, so because otherwise we'll be misled. Okay, so so let's all work on question 15 together, and then we'll pick up the stuff down at the bottom. Okay, so I'm gonna stop sharing this. And then I'm gonna share a whiteboard and we'll try to be quick about this. Okay. Can you all see the question just fine? Andrew?
Yes.
Okay. Okay. So I'll give you all a few minutes to work on it. When you have an answer, go ahead and raise your hand. Okay. So did you all get the same answer that I did?
Yeah.
Okay. Okay. So everybody's good with that. Now, the thing that hopefully, well, we'll go ahead and we'll go through these really quickly. So 16 says what's the intercept of the cartel's joint marginal cost function, and I'm assuming you all got that one too. And let's ask that, and maybe one thing I can do really quickly, let's just I'll add a whiteboard, and just to make sure that we're all on the same page. So this is 16. And this is 17. By the way, I didn't get a chance to ask you all. So Scott, how are you doing this morning?
A little bit tired, but doing well.
Yeah, I'm a little bit tired too. Haven't gotten my coffee all the way in me yet. Were you able to look at your scores from exam 2 on lithium, and was everything good?
I haven't checked it. I have to look for the sub questions.
Okay. So is it because you had to use sub questions for yours? Is that why?
Yeah, so I'm trying to find time to do all that.
Okay. Anyway, all right. Did anybody else? Andrew, did you get a chance to look at yours?
Yes.
And was everything fine for you?
I believe so. Yes.
Okay, good. And then I'm gonna put number 20 here too. Okay, boom. Okay, so we have all of the questions now. And so, but we can do our answers here. So this was the answer in this case to number 15. Okay. And so then number 16, do you all have an answer? Scott has an answer. Or you still have your hand up, Scott? Is it just
Still my hand up, but it's just the B80, right?
well, no, actually. Okay. And Brian, go ahead.
It would be 53, right?
Yeah, it's going to be 53. And so this ends up being one of the issues, and I will and again, you'd have to kind of go through the videos from this section very carefully, but I'll add yet another screen, and this is when the situation where if you don't graph it, it's like, I mean, I'm not saying you can't just memorize this stuff. You could, but for me, if I don't graph it, it's hard for me to see the intuition. So and this is where we have to be kind of careful with our language, because otherwise it'll get really tricky. And so I'm going to put output down here, and obviously Q, capital Q represents, and so you'll notice on my notation, capital Q represents both firms working together as a cartel. They act like a monopolist as if they were owned together, but they're actually, two separate companies. And that's the way that most monopolies form. You all might have heard of like price fixing and these types of things, which all have to do with forming a monopoly. But that kind of behavior happens when two companies act as if they're one. And that's the way that most monopolies in the real world form. Okay, so let's go ahead and take a look. So 53 and 106Q. So we know, right, that, and let's go ahead and graph all three of these functions. So the thing that's nice about this particular example is we know that for the individual marginal cost functions, that they're going to have exactly the same slope. So my illustration is going to be, pretty nice to look at, I think. So let's go ahead and we'll do, and the thing that's nice about this is we can clearly identify what we might call the high cost firm, because they're going to come in. This is going to be MC1. And so are you following me, Scott? And this is going to be um, 106. Okay. Does that make sense, Scott, so far? I'm just graphing.
Yeah, I think I wrote down the problem wrong. I have 53 for
And then,
MC1.
oh, actually, hold on, wait a minute. I may have it labeled wrong. So MC1 is 53 and MC2 is 106. So let me correct that.
I was about to be really confused.
No, it's okay. It's okay. Like I said, it's a little early for me. I don't really worry about these labels too much, though. It's important when you're explaining it, because the only thing that really matters for the substance of this problem is not the label, but that one of the firms is a high cost firm and one of them is a low cost firm. And hopefully you can see that in this example, the high cost firm is MC2, right? Yeah.
Yeah, I can see that.
Yeah. Now there's something else, and maybe I'll exaggerate it a little bit to make the point. So let's make this steeper. Maybe I'll make it really steep like this. But they're still parallel, right? Okay. Now let's look at the now. Now this is the we'll illustrate the other function, which is the joint marginal cost function, assuming that they both always produce. Okay. But it won't be optimal, meaning it won't be cost effective for them to produce. So in all circumstances. So that's what we have to be careful about. So it's going to look like this. Okay. And so we could actually call this, you know, something else. You know, it's a joint cost function, but it assumes that they're both going to be producing all the time. And so its intercept is going to be here at 80. And notice, hopefully, right, everything that I've illustrated, and I'm not even going to call it the joint marginal cost function, because again, I don't want to create a problem. But you see, this is what I graphed, Scott. Does that make sense?
Yeah.
Yeah. And we know, because for that line, right, that it has a slope that's half the slope of these other lines, and it's got an intercept in between their two intercepts. It's going to cross this MC1, the low cost firm's marginal cost function at some point, right?
Mm-hmm.
So this means if you were a entrepreneur and you were going to sell a low quantity of the good, what you do is you utilize your cheap factory first, right? But then at some point, now look what would happen. And I don't know if my illustration is really good. I'll try to make it even better. So notice what I'm going to do here, Scott, right? I'm going to say, okay, I'm going to try to find where this point is. So I'm just playing around with the line. Okay, so now I found it, right? And what point am I looking at? Well, I'm saying at some point, so is this making sense to you, Scott? So I'm saying, okay, I'm going to continue to produce at my low cost factory, but then I'm going to hit this point where, guess what I did? Since my marginal cost is increasing for my low cost factory, right? As I produce more and more and more, see how the costs are going up of producing? At some point, the cost of producing at the low cost factory, because of diminishing returns or, you know, diminishing marginal product, same thing, right? Increasing marginal costs, same thing, right? At some point, I'm going to drive up the cost of producing at the low cost factory such that it's equal to producing the first unit at the high cost factory. And at that point in time, right, I could produce a unit at the high cost factory for 106, right? But so what would be sort of like dumb for me to do, right, is it would be dumb if I'm trying to minimize my cost to keep utilizing this factory, right, and not utilizing the high cost factory at all. So I wouldn't want to do that. I wouldn't want to, you know, stay on this purple path, right? Instead, I'd want to begin producing at both factories such that I could produce more units for a lower cost by dividing the production between them. So now I'll correct my, you know, pink line that I made that point. So this should be at 80, and this line will cross right there. Okay. So, and this, let's see if it'll let me delete it. I'll try to move it out of the way. These pieces we don't want. Okay. So my true joint marginal cost function is this purple highlighted path, which is a piecewise linear function. And so I'll now call this MC. Okay. And joint MC. And I'll change the text color to, what color do you think that is? Is it lavender? Or I don't know. Who knows their colors really well? Scott, what do you think?
I'm the wrong person to ask.
What's that?
It looks, yeah, I know my colors.
Like lavender, something. I don't know.
Purple, pink.
Purple, pink, Barbie, purple. I don't know.
I know
sure
Barbie
there's-
as well, yeah, for sure.
Yeah. Well, I have 3 daughters. I know Barbie well.
Oh,
So,
yeah. You're with me.
so the main point is hopefully you can see now, and I'll go and grab the answer for number 16. Is that the answer for number 16, and I'll just put it down here. Okay, is 53. You see why? So Brian was right. Good job, Brian. But you see why, Scott?
Because it's gonna follow MC1 first.
Yeah, because you're gonna produce,
Okay.
when you're gonna produce a sufficiently small quantity, you're gonna produce, and we could actually label this quantity here if we wanted to. It's just, gonna be the intersection of these 2 lines. We know how to do that. It's like supply and demand. We could solve for it if we wanted to. But yeah, for any quantity that is less than, I'll just call it, I don't know, Q. Well, since I have the purple thing going, I'll just use the purple Q. If for any quantity less than the purple Q, I'll just use the small factory because that's going to be more efficient. Okay. And then, yeah, okay. So question 17, and are you okay with that, Andrew? Are you fine? It makes sense?
Yes, yes.
Okay. So then question 17 says, how much output will the cartel produce? Okay. So now this is where we have to consider the demand information. And so it's, PB is equal to 275 minus 8Q. Okay, that's fine. So I will, oh yeah, we have it right here. So notice that here, then the marginal revenue is going to be 275 minus 16Q. Okay. And profit maximization means we produce where marginal revenue is equal to marginal cost. Okay. Now, there is potentially a problem, and I hope you all see it. And that is, we don't really know whether, and I'm just going to deal with the marginal revenue function only. And I'll use, I guess I'll use, I'm picking the color right here. Yellow. So what we don't really know at this point is whether or not we've got a marginal revenue function that crosses over here, or that we have a marginal revenue function that crosses over here. Okay. And the one thing I'd like to point out to you is, are you with me? I'll talk to you, Brian. How are you doing, Brian?
I'm doing well. How are you?
Pretty good, pretty good. So the thing I want to point out is that if you ask me the best way to solve this problem and to be sure that I'm getting the right answer, there's kind of a little bit of work involved, meaning that you have to solve 2 times. Okay. So one candidate answer, right, is, and maybe I'll use red for this one. So it could be I have this crossing there. Okay. So that's one where I'm going to take the marginal revenue curve. And so this is marginal revenue. I'm trying to do it in yellow. Is the yellow show up fine for you? Can you see everything clearly? And I'm going to put a question mark.
Yeah.
Okay. And then, and I'm putting a question mark because, again, we don't know which one of these types of marginal revenue curves we have. We don't know. I mean, obviously, if you had a graphing calculator and you wanted to graph everything out, you could probably figure this out with a little bit of computational assistance from your graphing calculator, but you don't have to do that. And that's our other candidate solution. But what I want to point out to you is that what we would be comparing is, suppose we were to do, this, and maybe I should use a different color. Okay, I'll use a different color. I'm gonna take this and try to move it. Okay. So I'm gonna move that one there. And then I'll do blue rings for these other 2. Okay. So I'll do the red ones first. So comparing these 2 red rings, what could happen is if I do 2 solutions, right? I do the marginal revenue curve and I find the intersection with the joint marginal cost curve based on the joint production from beginning at 0. Not that I would ever do that, but it's just algebraically, it doesn't matter. So I find the solution of the intersection of those 2 lines, and then I find the intersection of the marginal cost of the low cost firm with marginal revenue. And then I compare the solutions, which are going to be 2 different quantities. And notice, Brian, I don't know if this makes sense to you, but if I have this type of equilibrium, and I'll kind of put this in red. If I have this, come on, it's not letting me choose. Okay. If I have this kind of, call it a red equilibrium, then the output that's larger will be the answer. Do you see what I'm saying? Because the joint marginal cost function crosses this candidate marginal revenue function at a higher level of output than it crosses the marginal cost of the low cost firm. You see what I mean?
Yeah.
So this is a greater Q than this one is, right? Now, if instead, right, I do everything the same way, and it turns out that I'm really dealing with, let's call it a blue equilibrium, then my two crossing points are going to be here and here, right? And in this case, right, the blue type of equilibrium, the output associated with the intersection of the marginal costs of the low cost firm is higher than the output associated with the intersection of the joint marginal costs and the marginal revenue. You see, so now this is greater. You see what I mean, Brian?
Yeah, so basically you're trying to say that we're gonna solve MT1 is equal to MR, and then we're gonna solve JMC is equal to MR, and we're trying to find which one has the highest quantity.
Yeah, and then whichever one gives you a greater output, that's going to be your answer for how much output the cartel produces. And, you know, and the thing that makes this problem kind of, different, unique, interesting, weird, or whatever you want to call it, is that normally, right, you just find marginal revenue equals to marginal cost. And again, if you graphed this out very precisely, you would know, oh, okay, I'm dealing with this type of equilibrium. I only have to find the intersection between this marginal cost function and this marginal revenue function, and I'm done. Or you might graph it and it might turn out to be like this. And then you would say, oh, okay, I know they're just going to be producing at their low cost factory. So I'm going to be dealing with this marginal cost function. And I just find the intersection of this marginal cost function with the marginal revenue function. And that's my answer. But because, the problem wasn't designed to require a precise graphing calculator, you have to do this kind of thing in your mind saying, well, I could be dealing with this blue type of equilibrium or this red type of equilibrium, and I don't know which one, but I know that if I calculate the solutions for the intersection of the low cost with marginal revenue and the joint with marginal revenue, whichever output's greater is going to be what the cartel produces. So I think you said it. Hopefully I helped by saying it over again, but are you good, Brian?
Yeah, I got it. When I did the homework, I just did the JMC is equal to MR and I got lucky, but I get what you're trying to say now.
Well, yeah, and you might not, because Ignithium, I will not guarantee you, is always going to give you that type of a solution. And that's one of the reasons why these problems are a little bit challenging for a lot of students, because they think, oh, okay, I'm always just going to be doing JMC MR. And that could be the case, but then all of a sudden you'll get one of these and on a problem set, and you'll go, oh, I thought, is the program messing up? Is there some problem with the Ignithium or whatever? No, it just gave you, an equilibrium you didn't expect. So, okay, this is instructive. So let's go ahead and continue on. I know other people have joined us, but this homework is due. So I want to finish helping you guys out with this. So we have 17. The one question I forgot to put in here was 18. And okay. So you guys work on 17 and then give me an answer. And does anybody have a hand they want to raise? And if you just joined us, we're working on the Monopoly homework, the problems toward the end. And this is kind of apropos where we left off last time. And I'll show you. So we've been talking about, and I'll post this lecture, but last time I left you in lecture, the thing that we hadn't done is we were working on the joint marginal cost function. And so the way to construct the joint marginal cost function is, so this is based on problem 15 in Ignithium, is to go ahead and I'm trying to move these controls around. Is to go ahead and see I have the two marginal cost functions of the two firms. And then the process I described last time was you take the marginal cost function and then you invert it. And I've inverted in 2 steps here. If you guys remember from algebra back in 9th grade, you know, inversion is just taking the variable that was originally on the right-hand side and pulling it over onto the left-hand side and rewriting the equation. So I'm taking Q here over to the left-hand side and then I'm solving for Q by itself. And then I did the same thing with the marginal cost function for firm 2. And then I go ahead and recognize when the two firms are going to be coordinating the behavior and acting like a monopolist, when they're going to be acting as what we call a monopoly cartel. then their output's going to be the sum of their joint outputs. And then I also have to recognize this when they're both producing, that there'll be no distinction. Their marginal costs will be the same. It's as if they're one big factory when we have the two factories joined together. So I can use that and just add these Q1 and Q2 together that I calculated, and I get this equation, but I have to turn it back into the form so I have the marginal cost isolated on the left-hand side. And if I do that, then in this case, we go from here to finally the joint marginal cost function of the two firms. And I also told the folks that came into the activity this morning, and the thing that we're working on right now, is that the problems here on this problem set are going to be different from the ones on the final exam, because the ones on the final exam will be simpler. There will be no intercept term for the equations that define the marginal costs of the two firms. So because of that, you won't have to deal with the problem we're dealing with right now, which is that this joint marginal cost function assumes that they both always produce. And when you have these zero intercepts, this condition will always be true. But on the homework, it's a little bit more complicated, because in some instances, only one of the firms will produce. And so this joint marginal cost function doesn't capture the true costs when only, in this case, the low cost firm is producing. And that's what we're talking about as we work through these problems. Okay, Brian, you had an answer for us?
Yeah, but I got 11.1 doing the MC1 is equal to MR, but I also wanted to point out, I think the MC we have on the board right now is off by 0.5. I think
Which
it's
one?
79.5. The
Where?
80 that you got when you combine
Oh,
the
did I
13.25.
oh yeah, you know what? I think you're right. So I take that back, because yeah, this, why did I, so this is the error right here. And I don't know why I did that. I guess just sloppy adding. So this should be 39.75, right? And then that multiplied by 2 is 79.5, right? Is that, oh,
Yeah, that's what I got.
I want to do the right steps here. Okay. And then I multiply by 2 and I got 79.5. Okay. Does everybody agree with all the math now? Is there anybody that objects?
Yes.
Thanks. Go ahead. Was there an answer? I mean, a question, comment? No. Okay. So, so, and here's the answer to number 17. Okay, good job, Brian. Does anybody not understand what Brian did? So now we get into number 18, and we should be able to handle this pretty quickly, because so this says consider blah 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 blah, how much output will firm 1 produce as part of the cartel. and so what type of an equilibrium did you get, Brian? Were they both producing? Or was just the low cost firm producing?
Wait, can you repeat that? You kind of cut off.
Yeah, I said, what type of equilibrium did you get? Did you get both firms producing or just one of them producing? Did you hear my question that time?
Yeah. Wait, I kind of blinked out right now. I don't know. Can you call it someone else?
Okay. No, I'm still gonna call on you because I think we're almost there. So which type of equilibrium was it? You see the illustration now. Did you
Like, was it I used to
solve?
solve the problem? I did the
Yeah,
MC1. Yeah, MC1.
yeah. So in this type of equilibrium, right, you're not on the joint portion of the,
Yeah, I'm
right?
on the
You're just,
MC1.
yeah. So that means only firm one is producing, right? Only the low
Yeah.
cost firm, right?
Oh, I get what you're saying. Yeah. So that means that MC2 would be 0?
Yeah. So
Okay, got it.
yeah. So I guess it's lucky we got this type of equilibrium because I think this one is maybe easier. I don't know, but I do want to point out one thing before we leave the topic, and so yeah. So the answer for number 18, because we just have one of them producing. And what about you, Andrew? Are you following this just fine?
Yes.
And so for question 19, how much will firm 2 produce? Well, we already know the answer, and Brian told us. And
Me? Oh, 0?
yeah. So okay, there's 19. And then the last question is this question 20. How much profit will firm 2 earn, right? So does anybody want to take a stab at that one? This one turns out to be really easy in this case.
It's negative 100.
Yeah, because if you produce 0 output, then your profit is just your revenue minus your cost. And yeah, sure enough, you earn 0 revenue, but you still have to pay your fixed costs. So I think that was a really nice exercise. Do you all have any questions for me? And the one thing that I wanted to point out, I'll point out in a minute, but since we just finished these questions, any questions, comments?
Yes, Professor. So, like, can you please answer, like, explain again for number 19?
Oh yeah, so we're in this kind of equilibrium. We're in the blue type of equilibrium, and in the blue equilibrium, only firm 1 is producing. So firm 2 produces nothing.
Oh, I see. Okay.
Okay. So but if we had been in this type of equilibrium, then they both would have been producing. And that's the thing I want to tell you all about next really quickly. And and I suppose to do that, I'm just gonna kind of play around with this diagram a little bit and see how good I can do. I'm just gonna move this stuff over here. that I don't want to talk about. So it's not a distraction. I think I told you guys this at the beginning. They did something weird to the whiteboard tool that it's hard to erase stuff now. So I have to just kind of like banish it over here in the corner. So okay. If we were dealing with this other type of equilibrium, and put this. Okay. If we were dealing with this other type of equilibrium, then the next thing to remember is just like a standard monopolist. We would set marginal revenue equal to marginal cost, but then there would also be a demand curve up here, and so I'll illustrate a little bit more completely. Okay. And let's assume this is our demand curve. It wouldn't look exactly like this because I'm gonna try to do the best that I can. But so there are two issues, and one of them is that if we had this type of equilibrium, and it's the illustration's not perfect, and I'm gonna try to give it a little bit more flavor of what it would look like. Notice that none of the stuff that I have here is drawn to scale. If I had done a better job of drawing it to scale, then the 80 would be down a little bit closer to the 53 and not quite as close to the 106 and all the rest of it. So I'm gonna move things around a little bit just to make the point more clearly. Okay. So my first point that I want to make is that when they're both producing, remember, and I'll put it down here in the corner in blue, that both producing implies that their marginal costs are equal. Okay, that's the first point. So when we want to see how much each of them is producing as part of the cartel, and hopefully, again, I'm going to make these parallel. Okay. Then the way to do that, and let me talk to somebody else. I'll talk to you, Brian, because you were chatting with me earlier. Can you hear me, Brian?
Oh yeah, I can hear you.
Okay. So the thing that you want to do, and I suppose I'll use I'll just use a black line, is you want to say, okay, this is the joint marginal cost, and now I want to divide the output between the two firms. So I'm going to just draw a line here like this. Okay. And then I'm going to move it down. And I'm only doing this so you all can see the level. If the whiteboard tool allowed me to make this a dashed line, I would, but that's not an option. So I'm just drawing a line. So you can see that line, right? And in fact, I can even make the line more like this so you understand that it's not part of the diagram. It's not bound by these axes. But you see the purpose of that line, hopefully. What it does is, and now I'm going to move this label around, and maybe I'll change the color to, well, okay, I'll just leave it as a purple one because I'm going to say that it identifies the joint production. But then when I'm going to look at the production for each of them, I'm going to say, okay, what this line gives me is it gives me the joint marginal cost. It's a dollar amount. Like the joint marginal cost is, you know, something like, and maybe to make the label fit a little bit better, but it's some amount of money. We didn't solve for it, but you would if you were doing this type of problem. So, but it's some amount of money. Let's just say it's like $123. So when both of these firms are producing, they're producing at $123 in terms of marginal cost for each of them. And that gives them a joint output level that's equal to this, you know, purple Q. But okay, Brian, you with me? When I look at the division between them, I'm going to say, okay, now I know the joint marginal cost is 123. So I have to evaluate the Q that gives me 123 for firm one, and that will give me the share of the output that firm one is going to produce. So I'll put it in orange here, Q1, and then I will take that 123 and substitute it into the marginal cost function for firm two, and I'll get firm two's share of output. So let's see if it's gonna. I'm trying to change it to a red arrow and it's not cooperating. So anyway, and that would be firm two's share of the output. So once I have their shares of the output, so do you see what I did, Brian? Does that make sense? Now I can get rid of this line. I mean, it's not doing anything for us other than helping me show you where I got the information from in order to figure out the shares of output of the two firms. Okay, so now you know where I got Q1 and Q2 from, right, Brian? Does that
Yeah.
make sense? Yeah. So once I know that firm one is gonna produce the orange Q1 amount of the total quantity, and Q2 is gonna produce the remainder, then the next thing I have to do is I can use those Qs to figure out the profits for each of them. And you all will remember, you know, that profit is equal to the total revenue minus the total cost. And so I'm gonna write it in the way that's easiest. So we need the price times the quantity for each of the firms individually. The price is gonna be the monopoly price. And then for each of them, remember the total cost is variable cost plus fixed cost. Well, the fixed cost will be given in the problem. The variable cost, remember, is just going to be the area under the marginal cost curve. So you have to do some calculations to figure out the variable costs for each of them based on their marginal cost curves and how much they're producing. So, but you guys have already worked with the cost curve, so I'm not gonna go over that again. The only thing that's missing is, and hopefully, and I'll talk to you again, Brian. Brian, you can see this. So this is the amount in the middle here that the cartel is producing, right? And for a monopoly, right, I go up to the demand curve, and that's not supposed to be a point of intersection between MC2, the red curve. It's just MC2 is still hanging out there. I could get rid of it if I wanted to, just to be clearer, right? And then once I find the height of the demand curve at that level of output, then I can find the monopolist price over here. Okay, let's be a straight line. So if I had this red type of equilibrium, the problem would be more complicated in the sense that to calculate the profits for each of the two firms, I would have to figure out how much output each of them is producing, and then figure out their associated costs, and then find the monopoly price. And from the monopoly price, calculate the revenue that each of them earns. Okay, does that make sense, Brian? Does anybody have any questions about that? Question. I also want to point one other thing out. And are you with me, Brian? Like still?
Yeah, I'm here. Yeah.
Yeah. So this type of thing is what's going to show up on the final exam. And you know why, Brian?
Because it's difficult and it has a lot of stuff to learn.
No, because remember I said on the final exam that there are going to be no intercepts, right?
Yeah.
And if there are no intercepts, there's no low cost firm in terms of, you know, that we can distinguish on the basis of the height of the vertical intercept, right? So what that means is that they're both going to be producing all the time, which means that in one sense, your job will be easier because you'll always be finding the intersection between marginal revenue and joint marginal cost. You won't have to worry about this exception. well, I guess the exception was down here or whatever, but it's the other thing that we were drawing, right? You won't have to worry about the other case, but you will have to go through and calculate the profits after you find the monopoly price. Okay. And I'll just label this PM for monopoly price. Okay. Okay. So does anybody have any questions for me about that? No. Okay. Okay, no question. Okay. All right. So we answered all the questions and I pointed out to you how it was going to look on the final. Okay, so I'm going to go ahead and stop the recording.